Good morning. Today's lesson is on graphing systems of linear inequalities. So you will be given something like this. It says x plus y is greater than 6 and 2x minus y is greater than 0. So you have to graph an equation of a line. A couple things that you have to think about. If it's just greater than, and so this is something that you need to remember too, greater than or less than will be a dotted line. If it's greater than or equal to or less than or equal to, it will be a solid line. Okay, so a couple things. Now, when we graph them, you can solve for y and graph it with this slope and the y-intercept, or you can graph using intercepts. And that's what I'm going to do. I'm going to have x plus y equals 6. So if I want my x-intercept, remember that means your y value is 0. So then I get x is 6. So at 6, 0, I would have a point. I'm going to do the same thing to find my y-intercept. So I let my x value be 0. So I get y is 6. Now, because it is just greater than, it is a dotted line. And then we have to determine whether we're going to shade above or below this line. And usually I use what's called the test point method. I pick a point. And a lot of times I pick 0, 0 because it's easy to pick. So if we're looking at this top equation and I plug in 0 for my x and 0 for my y, I would have 0 is greater than 6. And obviously that is a false statement. So we do not want to shade where 0, 0 is located. So we would be shading everything on this side of that line. Now we have to do the second one as well. I'm going to do the same thing. I'm going to do my x and y intercept. So to do my x-intercept, I'm going to let my y value be 0. So I'd have 2x equals 0 and x is 0. So my y or x-intercept is 0, 0. I'm going to do this one in a different color. Let's do blue. Now, if that's my x and y intercept, then we need another point. So in this case, it might be better to solve it for y. And so if I move that y over, I'd have y equals 2x. So my slope is 2, up 2 over 2, up 2 over 2. Again, because it's just greater than, it is a dotted line. Now this one, I cannot use 0, 0 as my test point because that is on the line. So you have to pick a point that's not on the line. So let's pick 2, 0. So 2, 0 would be over here. So if I plug in 2 for my x, I would have 4 minus 0 is greater than 0. Well, 4 is greater than 0. So that is the side of the equation or the line that I want to shade. So what you are actually looking for is the overlap to the shading. So the actual solution is just this region. And this is called your feasible region. Your feasible region is all the points that satisfy both equations. So the red part that I just shaded here is the answer to your problem. So when you're graphing linear systems, you have to determine whether it's a dotted line or a solid line. You have to graph the lines, use a test point, pick a point to figure out which side of that line you would shade on, and do that with both. And then you're looking for that overlap. So this red section here represents the overlap, and that would be all possible solutions that satisfy both equations. If you have any questions, please make sure you reach out and have a great day.